This video is on gravitational potential energy and gravitational potential. Question 1. The following problem refers to gravitational potential energy E sub p. Part A. Define gravitational potential energy E sub p. Is it a scalar or a vector? The gravitational potential energy E sub p is the work done in bringing all the masses of the system to the present positions, assuming that they were originally at infinity. Gravitational potential energy E sub p is a scalar. This is good for us because we don't have to deal with vector components. Part B. What is the equation of the gravitational potential energy E sub p of an object when it is near the surface of a planet? What is a general equation of the gravitational potential energy E sub p? What is the significance of the negative sign? What are the units of gravitational potential energy E sub p? So when we are near the surface of a planet, gravitational potential energy is mg delta h. And hopefully you recall that. In general, it's minus g mm over r. Same units, joules and joules. The negative sign tells us that gravitational potential energy is always an attractive force. Question 2. What would be the gravitational potential energy of a 5.2 times 10 to the 5 kilogram rocket orbiting Saturn at an altitude of 1 times 10 to the 4 kilometers? Saturn has a mass of approximately 5.68 times 10 to the minus 26 kilograms and a radius of approximately 6.00 times 10 to the 7 meters. So you could just plug in all the values and you get a solution. Now notice what r is. R is the distance from the center. It's not the distance from the surface. Question 3. The following program refers to gravitational potential V sub g. Define gravitational potential V sub g. Is it a vector or is it a scalar or a vector? The gravitational potential V sub g at a point in a gravitational field is the work done per unit mass that would have to be done by some externally applied force to bring a massive object to that point to some defined position of zero potential, usually infinity. Gravitational potential V sub g is a scalar. This is good for us because we don't have to deal with vector components. Part B. What is the equation for gravitational potential V sub g? What are the units of gravitational potential? It's minus gm over r. Has units of joules per kilogram. A minimum of one object is required to determine the gravitational potential V sub g at a point. This is important. Gravitational potential energy and gravitational potential are not the same. Compare the definitions, equations, and units. Question 4. Determine the gravitational potential at point P from 3 massive objects. Massive means they have mass. So, to bring these objects in from infinity, we have this equation. V1 plus V2 plus V3. That's how much energy it takes per kilogram to move these 3 objects to those positions. Question 5. What is the relationship between the gravitational field strength G and the gravitational potential V sub G? This is the relationship. So, example, determine the gravitational field strength at a specific distance from the center of a planet on a gravitational potential versus distance graph. The solution is to draw a tangent line and measure the slope to determine the gravitational field strength at that distance. So if you have a graph of V sub g versus r, just take the slope at any point and you could find little g. Question 6. What is constant in a gravitational equipotential surface? All points on a gravitational equipotential surface have the same gravitational potential. No work is required to move a mass along a gravitational equipotential surface. So it's like you're above the surface of the Earth and you're going in a horizontal line. You have the same MGH. Question 7. How much work is done in moving a mass along the same equipotential surface? Is 0 joules. Question 8. How much work is done in moving a mass along two different equipotential surfaces? State the equation. So it's like you're moving horizontally above the surface of the Earth. You have the same MGH, but then you jump up or you jump down. So now you're going to jump between two different equipotential surfaces. So this is the equation. Work equals mass times delta V sub G, where V sub G is equal to this, minus Gm over R. So this is your equation. So you could also take the area under a gravitational potential versus distance graph. Question 9. What is the relationship between an object's gravitational equipotential surface and gravitational field line? They're always perpendicular to each other. Question 10. Use a pencil and ruler, draw gravitational field lines and equipotential surfaces for each figure. So for the image on the top right, you just have a fixed uniform spherical mass. That's the image on the top left. The image on the top right, you have two equal masses with equal radius, equal density. They're fixed. This image here, you have two fixed uniform spherical masses with M1 having a greater mass than M2, much greater. So you can see the blue lines are gravitational field strength lines, and the green lines or green curves are equipotential curves. So if you only have one mass, that's a sphere, if you draw a perfect circle around it, that's an equipotential surface. If you have two masses, same mass, same density, same radius, it's like you're drawing an infinity sign or a number 8. And if you walk along any of these green lines, the same curve, you have the same potential, gravitational potential. Same thing with this.